Alright, let's try this again. So looking at this, you're gonna wanna know what your general formula is gonna look like. You don't actually have to write it out. If you see KB, you're gonna just assume there's gonna be an OH involved. If you see Ka, you're just gonna assume there's gonna be a hydrogen involved. So doing this first one, we're basically looking at like our stuff. You can write out an ice table if you want. I feel like they're gonna be kind of useless because we're not gonna be dealing with multiples in terms of like OH groups or in terms of hydroxides or hydrogen groups or anything like that. So pretty much every single equation is going to be K is equal to x squared over, and this write concentration, but I'll just write molar for concentration. So this is like this concentration here, or whatever, is this just M right here. With the idea that this X is going to be either H or OH, depending on your equation. So for this one, we're looking at KB, so we would say KB is equal to X squared over concentration, which is 3.00. And then this will give us that X is equal to, so we're doing 3 times 1.79 times 10 to the negative fifth, or whatever, and then taking the square root of that. So 1.79 times 3 times 10 raised to the negative fifth. And then the square root of that, oops. Actually, I put a thing in it. So we get that X is equal to 0.007328028. So this will give us a POH if we take a negative log of X. So negative log of that gives us 2.135. So then our pH is literally just 14 minus that. So then we would get 11.86498. So basically 11.86, roughly. In terms of if he gives you a drug like morphine, the idea is he's giving you a KB, so you know that this is a base. So you've got morphine on one side, which is a base, plus water. Is going to give you morphine with an H from here plus that OH group. Once again, it's giving us a KB, which is giving us a base, so we know that we're creating an OH group here. So then, same general principle, so we say that 1.62 times 10 to the negative 6, which is our KB is equal to X squared over 3.42 times 10 to the negative 4, which gives us some tiny ass numbers here. So then we'll say X is equal to really tiny ass number, and the square root of that is So then this gives us our POH, which is going to be the negative log of that answer, which is 4.62822.944, whatever. So then pH is going to be equal to 14 minus that, which is 9.37177. So approximately 9.37 for that pH. Hopefully these are really easy. So the reason I know that this is POH for this, I'm looking at the fact that this is a hydroxide here to make my H squared. If I was to draw out an ice table for this, I would literally just have morphine, then I would have my morphine plus my H on it, and then my OH, and I have my initial concentration. I have 0, 0, I have plus X, minus X, and then I have my concentration minus X, and then X, and X. But I know that I'm specifically looking for hydroxide from that. I don't try out ice tables. I don't really feel like you need to for this, but if it helps you think about what you're doing, keep doing that. In terms of the Delanton one, he gives us a Ka, but he doesn't specifically say that we're moving like hydrogen off of Delanton. But if you see a Ka and a drug, you should just assume that that drug is going to be acidic unless he tells you otherwise, with the idea that dilantin is therefore an acid, so it's actually going to be losing hydrogen. So my thing would look like this, a little negative off of it, with the idea that it has lost this hydrogen group here, which is then going to be over here. So he'll probably want you to like write it out like that, like, or if he has us write anything out, like you want to write it out like this, which is how he likes it. But I'm lazy and I usually just do H plus, so I usually just do that part. So the idea is then that we're looking for hydrogen. So my K is equal to X squared over concentration. So he gives us a Ka for this one, which is 5.01 times 10 to the negative 9. And our concentration is 2.87 times 10 to the negative 2. So then our X, which actually is our concentration of hydrogen, because that's what we're looking for here. We're looking for hydrogen, so our X is going to be hydrogen, is going to be 2.87 times 5.01 times 10 to the answer 0.000011991. And then once again, that's our hydrogen concentration, so our pH is just a straight negative log of this. So therefore pH is going to equal to negative log, so answer 4.92114189. Oh, there it is. Yeah, I feel like those are straightforward. I feel like the other problem set has some stuff that might confuse people, but hopefully that helps in terms of like how my thought process goes through this. But yeah, I'm gonna stop.